Hello, biology world. This is Paulus. The purpose of this video is to give you an opportunity to finish these class notes. Remember, we did the first half in class on Friday, and the second half you'll need to do on your own, and these are due Saturday night at 9 o'clock. Section 15.2 talks about the scientists that influenced Darwin's thinking. Again, one of the major reasons why he was able to make his breakthrough discovery and pull all of those ideas together is because he had an understanding of what other people were doing at the time. All right, so without further ado, here we go. If you want to mute me, so you'll see me doing this instead of making sound, feel free, but understand that I will be moving to the next slide when I point at the camera, just like always. All right, here we go. First two scientists we're going to talk about are Hutton and Lyell. So they helped scientists of the time realize that the Earth is many millions of years old. They were wrong. I mean, the Earth obviously is billions of years old. But remember, we didn't have access to the technology that we have today. Darwin knew that evolution would take a very long time. And once he realized from what other people were finding is that the Earth had time to do evolution like he thought. They showed that the processes that Earth changed in the past are the same processes that happen today. And I beg your pardon, it is lunchtime on Friday, and I'm famished. I will be eating during this video. I hope you don't mind. All right, here we go. All right, so Hutton, back in the late 1700s or late 18th century, published a hypothesis about geological forces that actually shape the Earth. And mentioned that these took millions of years. The importance of that is that at the time, the church suggested that God created everything, and that the Earth was more than just a couple thousand years old. And even more importantly, that there was enough time for evolution to have taken place. I'm going to shut this door behind me. All right. Lyell, on the other hand, he described processes that actually shape the Earth, and that the processes that currently can be observed shaping the Earth today, like weathering and erosion, plate tectonics, mountain building, all those processes that shape the Earth today are the same processes that shaped the Earth in the past. These are both geologists. Geologists study the Earth. Geo is the Latin root for Earth. And it's kind of near and dear to me because I actually got a geology minor when I was at Sac State, and that is what got me the job at Rio. They needed an earth science teacher that could also teach biology. Obviously, I got my degree in biology, but I got a minor in geology, so I had enough coursework to actually be able to teach earth science at Rio. And was the earth science teacher for about 10, 11 years. We no longer have earth science, which is kind of a bummer because it was a really, really fun class to teach. Anyway, one of the principles of geology, remember hypothesis, theory, principle, natural law. One of the principles of geology is called the principle of uniformitarianism. And that means that processes that are occurring today are uniform or are the same processes that were happening in the past. All right, moving ahead. We have a Hudson sighting and a wife sighting. All right, Lyell and geological structures. So he explained how geological structures like mountains, canyons, could be built up, mountains, and torn down over long periods of time. Most of the mountains that have ever existed on the surface of the earth have been washed away. Weathering by ice and wind and water breaks up the rocks that make up the mountains and carries that sediment away as erosion. Most of the mountains that are on this planet are relatively young. And when I say relatively young, I'm talking, a couple million years old, or maybe a couple 100 million years old, which is relatively young when we're talking about a planet that is 4.6 billion years old. This definitely did influence Darwin. He thought that if the Earth could change over time, that life also could change over time. Okay, if you must know, I'm eating homemade beans and rice. Man, I made the rice way too spicy this time. I mean, I can handle it, but not as enjoyable. All right, so how old was the Earth? These changes suggest that the Earth is extremely old, or most importantly, just older than a couple thousand years. All right, moving ahead. Please use this as an opportunity to practice with your notes rather than fast forwarding ahead. What were the name of two scientists that talked about the age of the Earth and the processes that are occurring today as far as being the same as the processes that were in the past? Take a look back at number 12. You got it. Lyell and Hutton. Which one believed that the Earth could not be a few thousand years old? Which one believed that the same processes that are operating in the past are operating in the present? And take a look back at number 13 and 15. Yeah, so Hutton was the age of the Earth guy. Lyell was the processes that are occurring today are the same as the processes that are occurring in the past. And most importantly, that these processes take a very, very long time. So it'd be Hutton and Lyell. Darwin wondered that if the Earth could change over long periods of time, whether blank could also change. If you're not sure, take a look back at number 17. Yeah, I believe that life could change over time as well. All right, here we go. Next scientist we're going to talk about is Jean-Baptiste Lamarck. He was a Frenchman. So anyway, he got a lot of this right, a lot of it right. But the most important thing, how evolution takes place, he got wrong. Okay. He did believe that living things changed over time. Ding, ding, ding. That's correct. He also believed that living things are descended. Whenever you see descended, you can write come from or came from. It means the same thing. From other species. Ding, ding, ding. Got that right too. He also believed that organisms were adapted to their environment. Ding, ding, ding. Got that right too. Moving ahead. So how do you think it happened? Second bullet, he thought these traits could be passed on to their offspring. Ding, ding, ding. Got that right. Over time, this process led to changes in a species. Ding, ding, ding. Got that right. But that first bullet, I got a problem with that first bullet. He believed that selective use or disuse of organs, things that are inside of us, or body parts, for example, legs, or in the example in the book, claw for a crab, that you used gave you different characteristics during your own lifetime. Now, let me use me as an example. Back when I was your age, I played a lot of sports. My favorite sports were baseball and basketball, but I was best at basketball. I had a really good jump shot and knocked down my free throws and decent defender. Anyway, I'm about the same size as I was then. I'm about 5'8", maybe a little shorter now because I'm starting to shrink as I get old. But I really wanted to be taller. I mean, like 6'1", 6'2", 6'3", 6'4", so I could dunk the basketball. I mean, I could barely touch the net as it was, right? So if Lamarck was right, okay, me dreaming of being taller, me dreaming of being able to dunk, me dreaming of being able to block people's shots, and willing that to happen over and over and over, one morning, presto, I woke up and I had been 6'4" with hops. Yeah, it didn't happen. Okay. So we can't change now. Trust me, if I worked out a lot, I do actually work out a lot, but I mean, if I worked out a lot, I mean, I can make my muscles bigger and I might be able to jump a little higher, but I'm not going to be able to dunk a basketball and I'm not going to be able to block people's shots. Okay. So, in a one lifetime, this cannot happen. Now I can pass on traits. My brother, he's 6 foot. My parents are both about 5'4", 5'5". Okay, so where did he get the tall gene from? Well, it turns out my mom's brother, Uncle Bert, rest his soul, he passed away about a decade ago. But Uncle Bert was tall. He was about 6'4". Also, my wife, she has 4 uncles, 3 of which are 6 foot or taller. So there is a little bit of height in my family. There's a little bit of height in my wife's family. And it's very possible that each of my boys could end up being taller. But it doesn't happen because they want to be. It happens because they got those genes from their parents. And as it turns out now, Gage, who's a junior at Rio, he's about 5'9". And his older brother, Logan, who graduated last year, Logan is about 5'8". So he's a little bit taller than me. Gage is taller than him. And, you know, who knows when they're going to quit growing. But you get it from your parents, not from using it or wanting it to happen. Okay. All right. Moving ahead. All right. So the example, and I love this example. Okay. So there's a crab with a tiny little claw trying to impress the ladies. Hey, ladies, check out my claw. So if it uses his front claw to scare away predators and to attract mates, and if he keeps using it and he really wishes he had a big claw, bam, he's going to have a big claw. Ladies, check out the claw now. Uh-huh. Yeah, you won't get with this, don't you? In any event, that's not how it happens. Okay. And then, of course, step 3, he did get right, Lamarck referring to, that large claw could get passed on to offspring. So if you have a gene for a big claw, you're going to have a big claw. If you don't have the gene for a big claw, you're not going to get the big claw. But, you know, depending on, you know, what genes the mother has, you could end up with a big claw in offspring, even if mom and dad didn't have the big claw. It just kind of depends on whether or not that's a polygenic trait. It also depends on whether or not having a large claw is a dominant or recessive trait. Okay. So the second step, passing it on to the offspring, winner, winner, chicken dinner. First one, yeah, ladies, check out my claw, check out my claw. Over years and years, your claw becomes bigger. No, that's not how it works. Moving ahead. Actually, I'm not sure if we are moving ahead. Moving ahead. All right, so how did inheritance happen? So developed traits would be passed along to the next generation. And of course, we talked about this with numerous species, and we were talking about Mendel and Luther Burbank and people that were studying genetics and inheritance. Nope. Pardon me. He was not right. He got everything right except for how it happened. And the how is the most important thing. If you're trying to prove to people that evolution works, and it's not God that says, you have a big claw and you have a small claw, you have to explain how it happens. And of course, how it happens is natural selection. Characteristic in nature gives you an advantage, and nature selects you to live longer and to eat more and to have more mating opportunities and to produce more offspring. And then, of course, those characteristics get passed on to the offspring. Natural selection is the how. Lamarck did not have the how. And that's the most important part. Obviously, how traits were inherited, that came later with Mendel's work. And of course, Watson and Crick, who stole it from Franklin, remember, Watson and Crick, figuring out DNA replication, and how the code for living things is transferred from parents to offspring. So the work of all of those scientists illuminated how this process actually works. All right, moving ahead. What did Lamarck and Darwin have in common? Take a look back at number 19 and 20. So they both believe in an evolution. Both believe that things changed over time. Both believe that species descended from other species. They both believe that organisms are adapted or suited to their environments. They both believe that traits could be passed on to offspring. And they both believe that over time, the process led to changes in species. All of those things they had in common. But Darwin was able to explain how, and Lamarck was not able to explain how. All right, so how did he think species evolved? You might want to take a look back at number 20, bullet point number 1. Yeah, so he thought that they evolved by using something or willing things to happen, same generation. Okay, that's where he got it wrong. Was Lamarck right or wrong? He was not right. And the reason why he was not right is he could not explain how inheritance happened. He could not explain how new characteristics show up in offspring. He couldn't explain any of that. Darwin could. Moving ahead. All right, Thomas Malthus. You'll hear about Malthus in the movie that we started watching today, Darwin's Dangerous Idea. So he published a book stating that babies were being born faster than people were dying. The population was increasing. 3 primary things that affect the growth rate of a population: war, or competition, basically, famine, starvation, and disease. War, obviously, things die. Competition between species, things die. Starvation, obviously, things die. Disease, things die. What did Malthus think would happen to the human population? He thought that if we continued to grow so fast, eventually space to live, and we'd run out of space to live, and we would run out of food. We are running out of places to live, although we continue to destroy habitat of organisms, our competitors, and use that for ourselves. And there are many places on the planet where food has run out, that there's not enough to feed the population. Part of that's climate change. Part of that is just large population. So there is starvation. It's not occurring to the extent that I think he thought it would, but it is occurring. All right, moving ahead. How did Darwin use this information? He realized that Malthus's ideas could be applied to plants and animals other than humans, that there will be competition, that if the population gets too big, competition, war, some organisms getting food, some not, famine. And obviously, the larger a population gets, I mean, I kid you not. I mean, one of the reasons why COVID-19 has been such a problem for us is there are so many people on this planet. It's really easy to get transmitted when we have really dense population centers. Part of it obviously had to do with certain important people in the news and leading the country didn't think it was real and didn't think that wearing masks was a good idea. That was stupid. Yeah, I mean, large populations, dense populations increase the chance of disease. So Darwin took this human idea and he related it to all species, that there's going to be competition between organisms, and organisms that have an advantage: speed, intelligence, strength, okay, will survive longer, okay? And those that are weak, slow, or speed, strength, I forgot what the other one, they will not get as much food. They will not get as many breeding opportunities. And eventually those genes or those weaker characteristics will disappear from the population because they're not producing offspring with those same weak characteristics. Was Malthus right? He was right. Yes, absolutely. If all of the offspring of almost any species survived for several generations, they would overrun the world. Many people believe that humans have already overrun the world. Personally, I think that our population has already taken us past our carrying capacity. Personally, we're in for some problems, especially when the climate changes and gets really, really warm near the equator and people need to move north or south of the equator. And we start running out of food because sea level rise and destroys cropland worldwide. We're going to have some issues getting through the next couple centuries, folks. And I am not a pessimist. I mean, innovation, we definitely have the intelligence and the willpower to innovate and create new technologies that are going to get us there. I just think we've already gone too far, and it's going to be really, really difficult for the next couple centuries. All right, last one. How this helped Darwin? This information was central to his explanation of evolutionary change. That organisms with better characteristics, advantages in nature, would perpetuate those genes and characteristics by producing more offspring, and that competition was inherent in populations. He, like I said at the beginning of this lecture, Darwin was able to take a lot of information from a bunch of different scientists and use it to support his own ideas. Brilliant, absolutely brilliant. Probably the greatest scientific discovery in human history, probably. People would argue the Human Genome Project or genetics or discovering how DNA works. I disagree. I think Darwin's work is by far the most important. All right, moving ahead. All right. The only forces Malthus observed that worked against population growth, what were those three things? If you can't remember, you might want to take a look back at number... Where is it? I forget. 25. War, famine, disease. Good. How did Malthus's observations help Darwin? What was Darwin able to do? He took Malthus's work and he applied it to his own. You might want to take a look at number 27. Yeah, so he related what Malthus was using to describe what's happening with humans and apply it to all species, all plants, all animals. Opinion. Do you think we have overrun the world? Raise your hand if you do. Thumbs down if you don't. Wait a minute. We're not in class. I'm not actually going to be able to tally up how many people think that we're over the Earth's carrying capacity. All right. Okay, Hutton and Lyell recognize the geological processes A, B, C, or D. How did Hutton and Lyell help Darwin? They reinforced to Darwin that the Earth is many millions of years old, or most importantly, just older than a couple thousand years. Because Darwin knew that evolution takes time. The discovery of many fossils challenged the idea that at the time, people thought differences in species were unimportant. Darwin disagreed. He thought differences in species were extremely important. The fossil record makes it pretty impossible to suggest that species have not changed over time. The fossil record suggests that species have changed over time. Which of the following scientists proposed the hypothesis of selective use and disuse? If I use something enough or want something to happen enough, it's going to happen or it's going to get bigger. That was Jean-Baptiste Lavant. The scientists have proposed that the Earth is shaped by geological forces that took place over long periods of time. They made this one easy because they only put one of the geologists in here, but which one of those guys was a geologist? Yeah, Hutton. Last one. Darwin's reading of Thomas Malthus made him realize that living things produce more offspring than can possibly survive because there's inherent competition within and between species. Within the same species would be intra-specific competition. Between different species would be inter-specific competition. All right, ladies and gentlemen, that is it for the notes. Remember, make sure that these are in Cornell note style. Make sure that they are numbered. Make sure you get them turned in no later than Saturday at 9 o'clock. And I will see you in the Zoom. Or actually, I'll see some of you guys in class. Signing off.